CPM Pre-Calculus Section 3.2.2, number 67. So for this problem, it has two parts, A and B. And part A, it says, make a table like the one below and use any patterns you see to fill in the missing numbers. So if we look at this one right here, we have a couple of different numbers and a lot of missing spots on the Y section. So for this one, it says that the input is 625 and then the output is 4. Another one says the input is 1 and then the output is 0. Another is the input is 25 and then the output is 2. And then the last one that's given is the input is square root of 5 and then the output is 1/2. So if we look at X, a lot of the numbers have to do with 5. So then that must mean that one way to think of it is that it might be you might multiply a number by 5 to get 625 or 1/5 or 5. So we're first going to check it out to see if it can be a pattern. So if we grab our calculator, for 1 we know that 5 to the third power equals 125. So if we try 5 to the fourth power, it equals 625. So we look back to our list, that can be an option, that the Y can be to the power of 5. Let's look at the second one, which is the input is 1 and then the output is 0. We take it to our calculator. 5 to the 0th power equals 1. So then that checks out too. Another one is 25. The input is 25 and the output is 2. So we put it in 5 to the second power, it equals 25. So that one will check out too. So now we're just going to go through and try plugging it in. So 5 to the what power equals 1/5. So we set it up like this. 5 to the y power equals x. And so x right here in this case is 1/5. So then we'll have it 5 to the y power equals 1/5. So let's try plugging into our calculator. 5 to the 0 power equals 1. So then it's got to be lower. It's got to be lower than 1 because it's 1/5. So let's try 5 to the negative first power. 5 to the negative first power is an error because you can't have a negative in your as an exponent. So if we have it 5 to the negative first power, in order to make it positive, we got to do the reciprocal. And the reciprocal, to make it -1, the negative part disappear, is to put a 1 over it instead of 1 under. So now this turns into a positive. So then it'll be 1/5 to the first equals 1/5. So 5 to the 1 power equals 5. So 1/5 equals 1/5. And that checks out. So then this one right here is going to equal -1. For the next one, it's 5. And what is the output? So when we look for the output, we're going to use the same thing that we used here, the rule right here. 5 to the y equals x. So the next one says 5 to the y equals 5. And that's pretty easy. If you plug it into your calculator, then you'll know 5 to the first power equals 5. Alright, so the next one is 125. So, if 5 to the first equals, excuse me, I meant to put 1 right here. If 5 to the first equals 5, then 5 to the second equals 25. Then that means 5 to the third, we plug it into our calculator. 5 to the third equals 125. So then the y will equal 3. Alright, then the next one. It's already solved. Next one is -1. So now we have it 5 to the y power equals x. In this case, x is -1. So then it'll be 5 to the y power equals -1. So we already know that 5 to the first equals 5. Then 5 to 0, if we plug it into our calculator, 5 to the 0, it equals 1. And if we try to do 5 to the -1, it didn't work in our calculator, and so we had to use the reciprocal, and that equaled 1 over 5. And so that proves that -1, 5 to the y power does not exist for a -1. So we put D and E does not exist. And next one is 0. For 0, if we try 5 to the y power equals x, x being 0, so 5 to the y equals 0. We can look back again that it can't have a -1 because it'll be less than 1, which is 1 over 5, and then we can try plugging it in into our calculator, but it wouldn't work. So then that does not exist as well. And then this one's already given 25, and the output is 2. Then the last one is 1 over 25. So then we use the equation that we got again. 5 to the y equals x. This time x is 1 over 25. So 5 to the y power equals 1 over 25. So if we look back to the other one that we had, which was 5 to the y equals 1 over 5, we had to do the reciprocal in order to get it 1 over 5 to equal 1 over 5. So we can try that again. Instead of using -1, let's try -2. So 5 to the -2nd power, if we get the reciprocal, it'll equal 1 over 5 to the 2nd power. And then 5 times 5 equals 25. And then you bring it back to over 1, then we get 125, which means that the output for this one is 2. For part B, it says express x as a function for y. So, for this one, we did that already, where x is a function for y, and then for our rule it was 5 to the y equals x. And that's the end of CPM Pre-Calculus number 67 of 3.2.2.